Hello. So this is our group, which include Fadwah, Era, Amalina, and Shikin. So this is our question, which we want to minimize fx x1 plus x2 and subject to these two constraints. Okay, so we want to solve the above problem, this problem by using SUMT. SUMT is defined as sequential unconstrained minimization techniques. So there are two methods actually. First is reciprocal function and logarithmic function. So we choose to use logarithmic function. So we choose logarithmic function to solve SUMT, and we choose G constraint as this one. So negative summation mi equals to 1 ln of constraint. So from this question there are two constraints here. So when we want to minimize, you can see second constraint is less than 0, so we have to make it more than 0 because we want to minimize, right? So x2 minus x1 squared more than 0. Okay, so and then it is easier to when we get one constraint only, but this question there are two constraints. So how to get this one? So we choose G constraint Ci is equals to like this, and then there are two constraints, right? So the summation of two constraints is equals to negative ln C1 plus ln C2, and close the bracket. And then therefore we get the transform function of this problem like this. So the first order necessary conditions for optimum of Px Rk is, so we have to make a partial derivative. We have to make a partial differentiation of x1 and x2 because there are two unknown. There are two unknown here, x1 and x2. So we have to use partial differentiation of x with respect to x1 equals to 0. So we get 1 minus Rk, and the differentiation of this one, and then here differentiation of this one. Also same to partial differentiation with respect to x2. We get here this like this, and then we can see that both partial differentiation is equals to 0. At setting, partial differentiation of x1 is equals to partial differentiation of x2. So we have setting partial differentiation of x1 equals to partial differentiation of x2. So we eliminate we eliminate 1 here because these are same. So eliminate 1, and then eliminate Rk also, and then we get here like this. Okay, and then right now we want to express x1 in terms of x2. Okay, since we want to make the denominators both of the side, left hand side and right hand side same, because we want to add this one and this one, so we have to make a denominator same. So this one we will multiply with x2 minus x1 squared, and this one we will multiply with this, right? Okay, so we will get like this. Both this one is in left hand side, right hand side also we have to use that method too. Okay, and then we want to express x1 in terms of x2, right? So since both denominator is not equal to 0, so we can use only the numerator. So this is numerator that we can get. So how to express x1 in terms of x2? Okay, since we want to find x1 in terms of x2, right? So we will compare. We compare both sides, left hand side and right hand side. So in left hand side, we can see this value is the same as this unknown value here. So we compare 4 minus 2x1 is equals to 4 minus 2x2. So we get x1 is equals to x2. Same also with this one and also this one. Same also with this one and also this one. We compare both. Negative 2x1 is equals to 1. So we get x1 equals to negative 1 over 2. So from here, we can see that we get a 2 value here. x1 equals to x2 and x1 is equals to negative half.
Okay, let's continue. Remember, we have 2x1. First, we have x1 equal to x2 and x1 equal to negative half. Okay, first we solve x1 equal to negative half. We need to find x2. Okay, first we substitute x1 equal to negative half into partial derivative respect to x1. So, respect to x1 or x2. We have two choice. So, in this problem, I show only one because both derive same answer. Okay, first substitute. This one replace x1 replace to negative half. All of this equal to 0 and we get this. We solve this. And then we separate RK into each function. And this one RK we bring to the side. So we have positive RK and positive 1. Like this. And then we make the denominator equal. So 5RK times to x2 minus 1 over 4 and RK times to negative x2 square plus 4x square minus 37 over 4. And then we get like this. First we get the like this denominator over this one. And then we bring this, we multiply the denominator. So 1 times the denominator and we get this. So I have no space, so I read the board. So we need to, and then we compare. Okay, we can see from this one we have this and this. It has same equations, so we assume this one and this one. So we have same function there. So we assume this is the
Both have same coefficient.
Coefficient. So we compare RK equal to x2 minus 1 over 4. So we get this. And then we want to find x2, right? So we bring x2 to the left hand side. And then we let RK approach 0. So x square equal to 0 plus 1 over 4. And then we get x2 equal to 1 over 4. Same as the other partial derivative, we get x2 equal to negative 1 over 4. So we get, we get like this. x1 negative 1 over 2 and x2 is 1 over 4. And then we will continue to x1 equal to x2. Thank you.
So next, we will proceed with x1 equal to x2. So we can either substitute into partial derivative respect to x1 or partial derivative respect to x2. So I will show you on partial derivative respect to x1. So we substitute all the x2 with x1 equal to x1. So we got these equations. So before we get this equation, we will bring this part to the right hand side, and we will get like this to make our works more easier. Then
we will
We will make a denominator same.
we will make a denominator same. And then after we make the denominator same, after same just like before this, and then we will bring all the denominator to the right hand side, so we will get like this. And then we will use same method, which we will compare left hand side and right hand side. Then we will get like this. So we get this part with this part, and then this part. After we compare, we take this part, so we got this 2x1 RK equal to x1 minus x1 squared. So after we solve, we get quadratic equations. So since we cannot solve by factorize by simple quadratic, we need to use quadratic equation quadratic formula, which is negative b plus minus square root of 4b squared minus 4ac divided by 2a. So here our a is 1, a equal to 1, b equal to negative 2 RK minus 1, and c equal to 0. So substitute all this into this equations formula, then we get this. So after we substitute all this, and we get this equations, and then we got this. After we solve this, we got half plus minus square root of 1 over 2. So it's square root of 1 is 1, so we got 1 half plus minus half. So we take the negative 1, because we want to, our objective to find the minimize. So we take the minimum one, so half minus half is 0. So we need since we have two possibility, just now we have x1 equal to negative half and x1 equal to x2. We need to find the minimum one. We have to substitute in our original function, which is fx equal to x1 plus x2. So for this, when x1 equal to x2, our x is 0, 0, x1 is 0, x2 is 0. So our function is 0 plus 0 is 0. For the x1 equal to half, this is our x, negative half, and x1 for x1, x2 is negative 1 over 4. So when we substitute in our original functions, we get negative 3 over 4, which is negative 0.75. So between 0 and negative 0.75, the minimum is this one. So our final answer is x is negative half and negative 1 over 4. So that's all. That's the answer for our question. So thank you.